Okay, today we're going to look at vertical and horizontal translations of lines. That means basically shifting them up or down. And we're going to start with the line y equals x. Okay, so we got here y equals x. I'm going to make an xy table, and then we'll take a look at its graph as well. Actually, let's do 2x. So I'm multiplying each x coordinate by 2 and getting my y coordinates. I'm going to go ahead over here and plot them. I've got -2, -4. And here's my line. To do a vertical translation, all I do is shift the line down. So instead of 3, 0, 0, let's shift it down 3. I'm going to shift each point down 3. So down -2, we'll go to -5. So to -4, we'll go to -5, 6, 7. Instead of 2 here, we'll go to -1. And I end up with the same line, just shifted down. Looking at the XY table, shifting each point down 3 subtracts 3 from the y coordinate. You'll notice my y-intercept is now, instead of being 0, it's -3. So my line becomes y equals 2x minus 3. So my slope-intercept form, all that changed when I shifted was my y-intercept. We're going to shift to the right 3 now and do a horizontal translation, which means I'm changing my x coordinates. I'm going to keep my y coordinates here on my original the same. I'm just going to shift my x coordinates. Let's go 4, actually. I'm going to go to the right 4, try to make them not overlap as much. So shifting from -2, going to the right 4, I add 4 to that, and I get 2. -1, I add 4. 5, 6. My y coordinates aren't changing. All I'm doing is shifting the x coordinates. Now instead of my y-intercept here, I'm looking at my x-intercept being at 4. And pardon my drawings not being perfect on here, but you'll notice that all of these lines are parallel. When we write this one with the x-intercept, remember factored form for the x-intercept is the number in the parentheses, and it's always opposite this sign. So the sign being negative means my x-intercept is actually at +4. But all of these parallel lines have the same slope. That same slope being 2. And for lines that have the same slope, they are always parallel. So anytime two lines have the same slope, whether that slope is -4, if I have two lines with a slope of -4, they're parallel. If I have two lines with a slope of 1/7, they're parallel. Okay? Slopes of parallel lines are always the same. So I can say, write the equation for the line parallel to this line through this point. Okay? I know my slope of my current line is 1/2. So that means also that the slope of my parallel line will be 1/2. Now I have a slope and a point. So I want to use my point slope form, where my slope goes in for m, this being my point slope form here that I'm writing out. And my x and y go in for x1, y1, not for x and y. This coordinate here, the x coordinate goes in here, the y coordinate, x coordinate goes in here for x1, the y coordinate goes in here for y1. It is opposite the sign. So I get y minus 2 equals 1/2 x minus 3. Okay, here is my equation for the line parallel to this one. Now, we do want to put it in slope-intercept form, just like my original line, y equals 1/2 plus x plus 4. That's slope-intercept form. So I'm going to start by doing that by getting rid of my parentheses by distributing. So nothing happens to my left side. When I distribute, I multiply 1/2 times x, and I multiply 1/2 times -3, and I get -3/2. Finally, I must move my 2 to the other side. That was -3/2. Leaving me just with y on the left side, 1/2 x, and I need to add my fractions. So to do that, I need a common denominator. 2 needs to be over 2, so that's 4 over 2. The common denominator is 2, so I must multiply my 2 by 2 to get the 4 on top. -3, when I add the fractions, I add the numerators. -3 plus 4 is 1, and the denominator stays the same. Here is my equation for my line parallel to my original through my point 3, 2. Let's make a cleaner drawing of that. Okay, and that is the translation of lines vertically and horizontally, and writing the equation for a line in slope-intercept form that is parallel to a given line and through a given point.